Good morning, it's the 25th of the 9th, 2021, and today we're looking at the Giza Great Pyramid and the calculation of root 5 by Crowhurst at Karnak, Tom's megalithic inch of 0.816 imperial inches, and the various royal cubits that have been derived by Neal, Algernon Berriman and Michell. And we're going to look at the way that these people use an averaging method for calculating universal constants. And we're looking at root 2 initially because Berriman gives us the root 2 calculation. And I've used that calculation to derive some of the other universal constants, for example, root 10. And I'm going to take you through the process. But before we do that, let's have a look at this book by Crowhurst. It's called Karnak the Alignments, When Art and Science Were One, Volume 1. Volume 1, he's obviously got something on mind when he's put Volume 1 there. Perhaps he thinks there's going to be a Volume 2. But anyway, if you're interested in Tom's work and in historical metrology, then you must buy this book. And we're going to go to page 18 and 19. 18 first. And this is this is Crowhurst's work on Alexander Thom's analysis of the Lamennec West egg and the associated stones that are aligned against this starting point. And we can see that Crowhurst has done a huge amount of work here. He's found true north. He's found a square with side 105 megalithic yards. And he's found triple squares, 1, 2, 3, 4, 5, 5 consecutive squares. And these squares are aligned to true north, and then they were aligned against the rows as they move away from the egg. And on page 19, there's some incredible stuff by Crowhurst. I think this is one of the most amazing pages of any book about metrology that I've ever read. And he's going on about the calculation of root 5. And he's saying that it's calculated as 19006 divided by 8500. Or it can be calculated as 42500 divided by 19006. And he's finding in his calculation for root 5, he's finding that pi as 3.125, Babylonian pi, is used in the calculation. I mean, to be able to find that using Tom's megalithic yard in the numerator and the denominator is something quite amazing. And he also suggests that the table stone and the cromlech is contained in a perfect square whose sides measure 105 megalithic yards. And the Aubrey circle diameter that Tom discovered at Stonehenge is 105 megalithic yards. It's beyond coincidence. And it puts the two monuments in the same time frame, whatever time frame that is. I'm not going to talk about that. So we can look at what Berriman's given us for this calculation of root 2. Now there's a lot of roots going on here, root 2, root 10, root 5, root 3. And I get a bit mixed up. I have to apologise for that. And sometimes when I'm talking about root 5, I say root 2. Because I'm so used to talking about root 2. So please bear with me if I'm using the wrong, if I'm saying root 2 when I mean root 5 and vice versa. I think you'll get what I'm actually talking about, even though I'm saying the wrong figures at times. So let's start using Berriman and root 2. And he gives it to us as 99 over 70 and 140 over 99. And this is a reciprocal arrangement where we multiply them together, and that cancels out, and we get 140 divided by 70, which is 2. And that's the way they were doing it. And we can work out what root 2 is as an average by adding these two together and dividing them by 2. Then multiplying that by itself, we get this fabulous calculation of root of 2, which only breaks down on the 9th decimal place. And then the 1 from Excel is this, and that multiplied by itself actually gives 2. So we can see the difference, and it's 6,4 there and 6,2 there. So what a fabulous calculation this is that Berriman has given us. And this methodology that they've used here then, I started to look at other universal constants, and the first one was root 10, because I realised immediately that Egyptian pi must be an approximate for root 10. Look at it, there it is, 256 over 81, and there's root 10 from Excel. Multiply that by itself and you get that. So look how close they are. It's easily close enough to be an approximation. So I went through this method here. 256 divided by 81, and we want 10 when we cross multiply. So we put 810 there and 256 there. Multiplies out at 10. We've got these two versions of root 10 that can be added together and averaged. And we multiply together, and that's a calculation. They must have believed that they were actually using the fractional correct version, because they were using whole numbers and they were so close. So now we're going on to root 3. Very important, this one, because it works with Tom's megalithic yard, and it produces a version of pi that can be used with the megalithic yard, and I've already been through it in the series of presentations, so I won't go through it now. But the first version of root 3 approximate is this 52 over 30, and we can see 52's in it, and we know there are 52 weeks in a year, and we know 52, when we divide it by 30 gives that, but the unit that Tom was suggesting that they use was 173.33 days, because that's an eclipse danger period. When you apply that to the nodal cycle, you know when the nodes are going to be aligned in such a way as an eclipse will be possible, because the penumbra will be vertical when you look at the moon. And that happens every 173.333 days. And that's what they were working with at Stonehenge, this version of root 3. So we multiply that by 3 and put the 52 as a denominator, and we get this second version, add them together, and that is a lunar count. 346.4 divided by 12 is a lunar cycle. So we can see that they were using these universal constants and moulding them into astronomical cycles by using whole numbers and producing astronomical counting devices like this one based on 52. And we've confined this at Stonehenge, even though we're working at Giza with this. So when we multiply that by itself, we get 3 with this breakdown, and that's the actual number. So we can see that it's close enough because this is a fractional approximation. And then we go to root 5 using the same method. And when I saw how Crowhurst work, I got very excited, because immediately I saw this number 19006. I knew that I'd been using 19008 in a lot of my calculations. For example, the cubit. No, I'll use 20.83. That's the base 100 cubit. When we multiply that, we get the metre. So the cubit times 1.9008, which is a fixed ratio, gives the metre. Any cubit. So if you want to use divide by 1.9008, that's the cubit that's coming out of that length of metre. So this 19008, I thought immediately I've got to substitute that into Howard Crowhurst calculation, which I've done here. And we're going to get to Crowhurst calculation next, and you'll see exactly what I'm on about. But this is totally amazing. We've got 19008, which is 3.6 times 5280. And we've got 8500 giving that approximate, and that's root 5. So we've got that approximate, and then we use the same method, multiply that by 5, and put that underneath, and we get this. And we can also have it as, divide that by 3.6, we get that, and divide that by 2.72, and we get that. Now those aren't producing that number there, so I'll delete those, but I just wanted to show you that they can be produced. So we've got this version of root 5, and now we're going to go to Crowhurst at Carnac, because this is what he's discovered. 19006 divided by 8500 is 2.236. What a fabulous approximation of root 5 that is. And we can use this method because we can, well, first off, I've divided that by 2.72, and I've divided that by 2.72, and we get this 3.125 Babylonian pi, producing the same result. And what Tom said was the circumferences, they use Babylonian pi in them to produce units of 2.5, and we divide that by 2.5, we get 2795. So we can see that that's exactly correct what Tom said. He mentions it in his first book very early on, that he suspected that they were deliberately using 25/8, which is 100/32. And that's Babylonian pi. So now we're moving down to these calculations of the cubit, and this here is the cubit used by John Neal and John Michell, and it's this times 176 divided by 175. And what we're really interested in here is this number, which is that times 1760, because that's the Giza base that Neal and Michell are telling us was the standard, and that is it in feet. And that's divided by 12. Divide by 12 again, we get that, and 12 again we get that, and 12 again we get 1.76 as a unit. And you've got to say that you can see the complete logic of what Neal and Michell have done here by producing this system. And we're going to reinforce it by getting this number from Tom's work and from Crowhurst's work at Carnac. But instead of using Crowhurst's root 5, we're going to use my calculation of root 5. And we're going to get this number here, 3649536, by dividing 816, which is Tom's base unit. We're going to divide it by root 2. And we can look, because we're using B27 for root 2. And it's that. And what is it? 42500 divided by 19008. And what we've got here is that's the imperial system. It's 5280 times 3.6. And that's Tom's system. That's base 17. That's base 11. And when we produce that value for root 5, we get this calculation here. 816 divided by root 5 gives 3649536. And that's produced by this cubit of Neal and Michell. So everybody's work now has been reconciled. And I could carry on to go down to this cubit here, using these calculations. And what's interesting is when we use that, we get this wonderful set of numbers here. And there's 3024, there's 3025. So that is linked to that. And that is linked to that, the beautiful set of numbers there, Not so clever here, and not so clever there, but the link is here. This is the Giza base in feet. And that all those units are linked together. But we've produced this from Tom's base unit using root 5. It's an absolutely sensational calculation. It's not doing anything other than marrying the work of all these metrologists together. And one of the things, excuse me, one of the things that John Neal has failed to realise is that he's produced that as a geodetic cubit, and Berriman has produced it as a royal cubit by using root 2, and that is multiplied by 140 over 99. That's the Riemann, that's the digit, and that's the cubit. Now there's one final thing that I want to put in here for Charles Magna, because Charles has flagged the fact that they were using this unit of that times that, 69444. And what I've done is I've multiplied it by 10. So I've got that times that to give that. And when we divide that into my Giza base that I'm insisting is what they were deliberately intending to have as the base of the Giza pyramid in imperial inches, using the work of Colonel Vyse, when we divide it by this unit that has been flagged by Charles Magna, we get 5280. And I've been insisting for such a long time that this base 100 system is in the imperial system. And the imperial system can be used as base 100 and base 99. It's a system that's got duality embedded in it. So really that's it for now. And it's a very complicated piece of metrology, this, and it needs time to be absorbed by other metrologists, but it's very significant because it's pulling Stonehenge and Giza together. It's pulling the work that's being done by the Mayans, including the Zapal unit. Everything now is being pulled together. All the metrology is stacking up. There's nothing wrong with the work of John Neal and John Michell, but also there's nothing wrong with the work of Berriman or Tom or Howard Crowhurst. Everything is reconciled now. So we can sit back and admire what they've done and start to put together an analysis of the metrology behind all this. So thank you.